Good morning to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of Computer Science and Engineering, MLR Institute of Technology. So, coming to the divide and conquer strategy, it follows consisting of 4 applications for divide and conquer strategy. First application is binary search. Second application is quick sort, third one is merge sort, and fourth one is a under graphs. So first let us look at the first application of divide and conquer strategy and what is the time complexity, and we can understand the example of binary search with the help of example. So first of all, what is a binary search? So what is the meaning of search? Searching is the process of finding the location of element. Searching is the process of finding the location of element. There are 2 types of searching. One is called as linear search. Second is called binary search. There are 2 types of searching. One is called as a linear search, another one is a binary search. Searching is the process of finding the location of element. For example, 1, 2, 3, 4, 5, 6, 7. So what is the location of 4? Is the 4th position. That 4th position means called searching. So there are 2 types of searching. One is called as linear search, another one is called binary search. So what is the difference between linear search and binary search? In case of linear search, so we have to do the searching process and take the key element. The key element is compared with each and every element in the searching process. And the second thing is, in the case of linear search, elements need not be in the sorted order. No need to follow the sorted order for the linear search. While coming to the binary search, so in the case of binary search, the first condition is all the elements should be in sorted order. That is the first condition for binary search. All the elements should be in the sorted order. In the case of binary search, no need to check each and every element with the key element. Instead of that, we need to divide the list of elements into 2 parts. Based on that, we have to do the searching process. Let us look at the example algorithm for binary search. So first step is read the search element from the user. That search element is called as key element. That search element is called as a key element. The element which you want to search in the list of elements is called as a key element. Next, find the middle element in the sorted list. What is the formula to find the middle element? Mid equal to low plus high by 2. Low plus high by 2 is the formula to find the middle element. After that, after finding the middle element, compare the search element with the middle element in the sorted order. That means this search element is key and then mid element. We need to compare whether it is a equal or greater than or it is a less than. If the key element is equal to mid element, if the key both are matched, then display given element is found. Given element is found. We have to stop the function. We need to stop the function. If both are not matched, then check whether the search element is smaller or it is a larger, whether it is a greater than or it is a less than. If both are equal, then we have to stop the searching process. If the key element is, we need to observe whether it is a greater or it is a smaller. If the search element is smaller, that means key is less than mid. Key is less than mid. Then we have to repeat 2, 3, 4, 5. Then repeat the step 2, 3, 4, 5. And then for the left sublist of the middle element, key is less than mid, you have to concentrate on the left sublist. If it is a key element is greater than mid, then we have to go for the right sublist. No need to compare each and every element. Depends upon the mid element, you have to do the searching process, whether it is a key element is greater than mid or it is a key element is less than mid. Key element is less than the middle element, you have to search only in the left sublist. If it is a key element is greater than the mid element, you have to concentrate on the right sublist. So the first step is we need to take the key element from the user and find the mid element. The formula for mid element is low plus high by 2. Once that mid element is found, we need to take the comparison between mid element and key element. If the key element and mid element both are equal, then given element is found. If the key element is less than the mid element, then we have to concentrate on the left sublist. If the key element is greater than the mid element, then we have to concentrate on the right sublist. Let us look at some example for understanding of how the binary search will work. So if all steps are completed, if the element is not found, then we have to return the element is not found. After repetition of the process, element is not found in the list, we have to return as element is not found. Consider the list of elements. The element is such element is 12. Okay, there is a total 0 to 7 means 8 elements are present in the list. Key element is 12. Key element is 12. So the first element is called as low. Last element in the list is called as high. The position of low element is 0. The position of high element is 7. Please remember. So the first element in the list is called as low element. The last element in the list is called as high element. The address or position of low element is 0. The address of last element is 7. Okay. So that is the given description. So the key element is 12. We need to compare. We need to compare whether the key element is present in the list or not. So we have to start the procedure. We need to take the search element 12 is compared with the mid element. So what is mid element? Mid element equal to low plus high by 2. That means 0 plus total 10 elements are there. 8 by 4 we have 8 by 2 means consider 50. So 50 is 12. So 50, 12 is equal? No, it is not equal. Both are not matching and 12 is smaller than 50. It is smaller than 50. So we need to concentrate on the left sublist. We need to concentrate on the left sublist. That is 10, 12, 20, 32. I already told that in the case of binary search, all the elements in the list should be in the sorted order. If it is a 12, that is nothing but a key element is less than the mid element, we have to concentrate on the left sublist. We have to take only left sublist. Based on the mid, we have to divide the list into two parts, left part and right part. Again, such element is compared with the middle element. Total how many elements are there? 4. Okay. So that is 0 plus 3 means 3 by 2. It will get 1. So that means first position. So first position is to be compared. What is the element in the first position is 12. Key element is equal to mid element. Then element is found at index is 1. At index 1, the element is found. We can say that key element is found. Once the key element is found, we can say that search is successful. Search is successful. Next, again take one more example. Search element is 80. Now, 80 is compared with the middle element. Total 8 elements are there. Middle element is 50. So, 50 is key element is 80. Mid element is 50. 80 greater than 50. That means key element is greater than mid element. We have to concentrate on the right sublist. Okay, right sublist. Both are not matching. Key element is not matching with the middle element and 80 is greater than 50. So we have to concentrate on the right sublist. In the case of right sublist, what are the list of elements? 55, 65, 80, 90. Now consider, so this is the 50. So now we have to consider the 4 elements. Out of 4, the first element is 0, last element is 1, 2, 3. Total 4 elements, that is 0 plus 3 by 2 will get 1. So that is the first element is 60. 65 is compared with 80. 65 is compared with 80. So 80 is the key element. 65 is the mid element. Key element is greater than mid element. You have to concentrate on the left sublist, right sublist, that is 80 and 99. 80 and 99. So what is the element? That is 0, 1. We take 0 plus 1 by 2. That is 0. That means we have to consider the 80. That is 70. Key element is 80. Mid element is also 80. So the element is found. Element is found at the index is 7. At the index is 7. So that is we need to take the two lists. One is a left sublist. Another one is a right sublist. If key element is less than the middle element, we can concentrate on the left sublist. If the key element is greater than the mid element, we have to concentrate on the right sublist. Now let us take one more example for better understanding. There are 14 elements are present in the list. So the first element is considered as 1, 2, 3, 4, 5. Take the indexes. You can take the indexes start from 0 or it is a 1, that is your choice. 9, 10, 11, 12, 13. Total 14 elements are present. X equal to 151 is nothing but a key element. Okay, that is called as a key element. So low is 1. The address of low is 1. Address of high is 14. Well, that is address of high is 14. One calculate a mid element. Mid element is low equal to, that is mid equal to low plus high by 2. That is 1 plus 14 divided by 2. That is 15 by 2 will get 7. Don't consider the fractional part. We have to consider only integer part, 7. So now we need to compare. What is the position of 151? That is for 151 key value is 151. What is the mid value? Mid value is 7. Now consider what is the element in U of 7 is 54. So key element is greater than 54. We need to concentrate on the left part, that is the right part. Okay, right part means up to middle part. You have to concentrate on the right sublist. So in the case of right sublist, if it is a k element is greater than mid element, greater than mid element, try concentrate on the right part. And also one more condition is, so if it is a key greater than mid, key greater than mid, then low equal to mid plus 1. Low equal to mid plus 1. That means initially mid value is 7. So if it is a key is greater than mid, low equal to mid plus 1 means 7 plus 1 is 8. High is 14 only. Now again calculate the mid value. 14 plus 8 divided by 2. That is 14, 22 by 2 will get 11 is the mid value. What is A of 11? 125. 125. And what is key element? 151. 151 greater than 125. Again concentrate on the left sublist. And also low is mid plus 1. Low value is increased. That is 12. Then high value is 14 only. 12 plus 14, 26 by 3 we are going to get 13. What is the element in A of 13? 142. 142. But 151 greater than 142 again. So that is a low value is mid plus 1, that is 14. 14 plus 14 is 28. 28 divided by 14 is 14. What is the element in A of 14? That is 151. Key element is also 151. Element is found. Element is found at the index is 14. At the index 14, element is found. Now consider the same thing, x equal to minus 14. Now x equal to minus 14. What is low? Low is 1. High is 14. Mid equal to 7. Next, after that we need to compare. Minus 14. It is a key element. What is mid element is A of 7 means 54 minus key element is less than 14, then high equal to mid minus 1. So if it is a key value is less than mid, then high equal to mid minus 1. High equal to mid minus 1 means high value will be 1, low value is same as it is, high value is mid to minus 1, mid is 7, 7 minus 6, that is 7 minus 1 is 6. Next to find out 1 plus 6, then low is 1, high is 6, calculate mid equal to low plus high by 2, that is 1 plus 6 by 2 will get 7 by 2, consider only the integer part 3. Now compare key element, mid element. Key element is minus 14, A of 3. What is the element in A of 3? So that is, this is 1, 2, 3, 0. Minus 14 less than 0. Okay, minus 14 is less than 0. So that is key element is less than the middle element. Then we have to consider as a high equal to mid minus 1. That means 2. Again 1 plus 2. 1 plus 2 means 3. 3 by 2 will get 1 is the mid element. Again compare. Key element is minus 14. Then A of 1. A of 1 is 6. Minus 14 less than minus 6. So that is true. Then after that, if it is a true, then we have to consider as a low, minus 14 is greater than minus 6. Yeah, what is A of 1? So what is the element in A of 1 is minus 15, not 6, minus 15. Minus 14 is greater than minus 15. Low equal to mid plus 1. That means 1 plus 1. High value is same. 2 plus 2 will get 2. Next, what is the value in the way of 2 is 6. Minus 14 minus 6. Minus 14 is less than. So automatically high value is mid to minus 1. 2. 2 plus 1. 2 plus 1 means 3. 3 by 2 is 1. So in the element is not found. Minus 14 it is not present. Then we have to stop the recursive process. We have to stop the recursive process. Again consider x equal to 9. What is low? Low is 1. High equal to 14. How to calculate mid? Mid equal to low plus high by 2. 15 by 2 will get 7. Consider only the integer part 7. Now compare. Key element is 151. Then what is A of 7? 1, 2, 3, 4, 5, 6, 7. That is 54. 151 greater than 54. Then low high equal to mid plus 1. High equal to mid minus 1. 1. Mid to minus 1 means 6. Again calculate 1 plus 6 by 3. That is 7 by 2 will get 3. So 151, what is A of 3? Element in A of 3 is 0. 151 greater than 0. Okay. 151 is greater than 0. 151 greater than 0. What is the element in so that is A of 3. What is A of 3 is 0. The element in A of 3 is 0. So we have to calculate as a low value equal to mid plus 1. Low value is mid plus 1. So what is mid plus 1 means that is 4. 4 plus 6 means 10. 5. Fifth position element is found. So like that we have to calculate whether the element is present in the list or not. In the case of coming to the analysis of binary search, suppose the key element and mid element is same, then only one comparison is required. So that is called as best case. In best case, the time complexity is 1 to 1 comparison because the element, key element and the mid position contains the same list. So it is a big O of 1 is the best case time complexity. Worst case means the item is in the last possible division or maximum elements. Okay, we need to search each and every element in the list. How much of time complexity? Big O of log n based is the time complexity. Average case means the element is present in the somewhere in the list is called as a average case time complexity. So in the case of worst case, the element may be present at the last position, or we need to make the comparison of each and every element in the list. Even the element is not found, that is called as a worst case time complexity. The worst case time complexity is big O of log n base 2. So suppose the element is somewhere in between the middle, then we can call it as a average case. In the case of time complexity, best case is element is present at the middle position. Only one comparison is required. The time complexity is big O of 1. Element is maybe present at the last position, or element is not found, even though we have to do the searching process from the first element to last element, then it is called as a worst case time complexity. Then the time complexity is big O of log n base 2. Then average case means the element is present at somewhere, then we can call it as order of log n base 2. So in the case of these three are called as successful search. That means element is found. Unsuccessful search means element is not at all found. The time complexity for best case, average case, worst case is big O of log n. Now coming to the algorithm. So binary search. Algorithm name is binary search. A is an array. It contains the elements of 1 to n, which is in increasing order. That means all the elements is in the ascending order. N is the number of elements. That means n greater than or equal to 0. That means at least more than one element should be present in the list. X means key element. X means key element which is present. So and so on. If it is a return J such that X equal to of J, that means key element is found in the array list, we can return as X. Otherwise we can return as 0. 0 means element is not found. Element is not found. If the element is found, we can return the address of the array. Okay. So this is for unsuccessful search. This is for called successful search. So what are the initial condition? Low equal to 1. That means the first element in the list is called as low. The last element of array is called as high. Now we need to compare. This while loop is repeated. While loop is repeated until the condition becomes false. While low less than or equal to high. We need to compare low and high and calculate the mid value. What is the formula for mid value? Low plus high by 2. And we need to make the comparison. Key element we compare with the mid element. If it is a less than, we can concentrate on the left sublist, then high equal to mid minus 1. If it is a x value is greater than, we need to concentrate on the, so that is a right sublist. If it is a left sublist, and also high value is decreased. If it is a right sublist, low value is increased, then we can concentrate on the low value. So after that, if these conditions are not satisfied, okay, then we have to repeat the process until low less than or equal to high. This is called as a iterative algorithm. Iterative algorithm. So there are two conditions, whether the key element and mid element. Key element is equal to mid element, it returns mid. If the key element is less than mid element, we can concentrate on the left sublist and high value is decreased by 1. Then if it is a right sublist, low value is increased by 1. If both are not found, we have to search for the mid element. If this is also not found, we have to repeat the process until the key element is found. Even for all the elements have to be searched, even the element is not found, we can return the 0 for unsuccessful search. It is called as a iterative algorithm. Second one is a recursive algorithm. In the case of recursive algorithm, you have to use the recursive function and it is called repeatedly until the key element is found. A is an array, I is the first element index, low is the last element index, x is nothing but a key element. So where I value is in between 1 to L. I value is in between 1 to L. So that is x means key element. L equal to I. Suppose low element, high element both are equal, then problem is small. No need to search, directly we can return the mid element and return as a success. Okay, return as a success. Otherwise, we have to reduce the problem by calculating low plus high by 2. If the key element is equal to mid element, return the mid element position. Otherwise, if it is a x less than a of mid, that means key element is less than the mid element, concentrate on the left sublist calling the function. So whatever we have to discussed in the previous example, high equal to mid minus 1, apply the same function, call the recursive function. In the place of a only I value, L value is low value, that is high value is decreased as a mid minus 1 and x is a key element. Suppose x is greater than a of mid, we have to concentrate on the mid plus 1. That means that is a low value is decreased as a low value is increased as a mid plus 1, high value is same as it is x value. Like that we need to make the comparison until the element is found in the list. So what we have discussed now, what is meant by binary search, what is the introduction of binary search and some example problems, and also algorithms on binary search. One is a iterative algorithm, another one is a recursive algorithm, and also what is the time complexity for successful search and also unsuccessful search. Thank you.